Hey guys, welcome back. So today we're going to start looking at how to find the derivative. And remember that differentiation is all about finding a new equation, a derivative, from that equation. Remember the derivative is derived or comes from the original function or equation that we start with. For example, y equals x cubed. And we are going to form a new equation from that, which is going to tell us the gradient of a tangent to this function at any point. So when we are given an x value like x equals 1, we can know what the gradient of the tangent at that line is. And remember, a tangent is a straight line drawn so that it hits this curve only once at the x point that we're given. If it hits the curve twice, it's called a secant. And differentiation is all about the tangent. So we're going to look at some simple examples to start you off with finding the derivative. So let's look at our basic rule. If we have a function that is y equals x to the n, so when we have x to some kind of power or indice, the derivative is going to be given by n, so we're going to bring this n in front of whatever is here, which in this case is nothing. We're just going to put this next to the x, and it's going to be nx n minus 1. So whatever that power is, we're going to minus 1 now, and we're going to put whatever that power was to start with at the front, and this forms a new equation. This is our derivative, and this top one was our starting equation. Sorry that line's a bit in the way there. I'll just make it a bit clearer for you. Okay, so if we have y equals x to the n, then the derivative is going to be nx n minus 1. So let's look at some examples. To start off with, if we have y equals x to the 3, that is going to be given by the derivative is going to be, well, we're going to pull this 3 to the front, we're going to pull this down, and it's going to be 3x, and we're going to minus 1 off the 3, which is 2. And that's the derivative of y equals x cubed. The derivative is y dash equals 3x squared. What does this mean? Well, this means that if I want to know what the gradient of the tangent is at x equals 1, I now just know that I can just sub in x equals 1 to our derivative function, not the original function, because that's only going to give you the y coordinate, not the gradient. This gives us the gradient. Remember that the gradient is equal to the derivative of that tangent. So we know the tangent is 3, 1 squared. So when x equals 1 at 3x squared, we have a derivative of 3. The gradient is 3. That is how steep the slope is at that point. Okay, what happens if we have an equation like y equals 2x squared? Well, now there's a 2. There's already a number in front. Up here, I showed you that it was just x to the n would be nx n minus 1. If there's a number in front, what you do is just hold the number there and times it by whatever this part is. So here we know it's going to be y equals, I'm going to keep the 2 there, and I know that x squared, we have to pull the 2 down in front, which is 2x, and I minus the 1 here to get 1. And we know that this equals 2 times 2, which is 4, because we had that 2 in front. 4x is our derivative. Okay, so if there's a number in front, we just multiply it by the indice that we bring down. Let's have a look at another example. What happens when we have y equals 5x? Well, we know that if we followed the rule here, there's actually an invisible 1 on top of this x as the indice, and we have to bring that down to the front. So it's going, the y dash is going to equal 5 times, because we're leaving that number there, 1 times x to the 1 minus 1, which is 0. And we know that anything to the power of 0 is 1. So we end up with 5. So if you look at what's happened here is if it's y equals 5 to the x, the derivative is just 5. It's just the number before the x. And that happens with any case where you have just an x term and no indice above it, just 1, which is invisible. It's just going to be the number before it that is the derivative because it has a constant gradient. If you imagine what the line y equals 5x looks like, say it's something like that, quite steep, the slope is always the same. It doesn't change. It's always 5. Our gradient is always 5. That's why it comes out like this. So it's just the number before it. What happens if we have y equals 2? Well, now, if I was to graph this, y equals 2, and if this was our y and this was our x, would just be a horizontal line going straight across at 2. It's y would always equal 2 for that equation. What's the slope here? It's 0. It's a flat line. So that tells us that whenever we are given a number, just a constant like 2 or minus 5, if you're just given a number, you know that the derivative is just going to equal 0 because it's a flat line like this. Okay, so let's have a look at when we have some indices on the denominator. So let's say we have y equals 1 over x. Well, the trick with these ones is we always want the x to be at the top. I want this x up here. So how am I going to derive it? I'm going to start not by finding the derivative. I'm going to rewrite the y function. I'm going to write it by taking this x to the top. How do I do that? Well, we know this x has an invisible 1 above it, and if I move it to the top, it's going to become negative 1 because of our index laws. So now I have y equals x to the negative 1. I have the indice on the top. I don't want it to be on the bottom. Now I start differentiating it with our usual rule. So we use our normal process to get y dash equals, pull the minus 1 to the front, minus 1 times x, and I minus 1 off that to get minus 2. And we know that if we've got a negative minus 2, when I get my final answer, I want to make it a positive indice again. So I'm going to get minus 1 over x to the positive 2 because I've brought that back to the bottom so it becomes positive again. And our last type of question for these first set of derivatives, there are going to be some harder ones coming up in the next video. Let's just say we have y equals the square root of x. Well, we use the same rule here. We don't want to have a surd. We want to always have an indice at the top. So I'm going to make this y equals x to the half. We know that the surd, the square root out here, will become x to the half. And I'm going to move this up here to show the next line of working. If I differentiate this, and I should have done this one in red, we first of all rewrite the y before we do the derivative, and now I'm doing the derivative here, which equals, I'm going to bring the half to the front, half x, and I go half minus 1, which is minus a half. So I get y dash equals, and I want this indice to be positive at the end, and I better write this a bit smaller so we know it's an indice up there. I'm going to bring it back down to the bottom. So I'm going to get 1 over, the 2 is still in the bottom as well, x to the half. So I end up with y equals, and I'll just write this next to it for you so you can see it. I'm going to get y equals 1 over 2 root x. Now, if you can't see that, I'm just going to move this down here for you. There we have it. It becomes y dash equals 1 over 2x to the half, and then that becomes 1 over 2 root x. Okay, so I've written that to the left-hand side of the y dash. And I'll just fix that one up there as y dash. And that's how we start with our derivatives there. See you next time, guys. We'll look at some harder examples.